Okay, so let's get started today. We may not get through everything I hope to because we're starting about 15 to 20 minutes late, but it's not a big deal if we don't get through everything today. You don't need it for the labs that are due over the weekend and then next Saturday. So actually, I'm not sure if I have a lab due since I redid the labs. Make sure when these labs are due. Okay, yes. So you have a lab due essentially tomorrow night, and then lab 1 due a week from Friday night. So we're going to talk a bit about the labs today. So with lab 0.5 and with the checkerboard part of lab 1, what we're kind of giving you practice with is chars. And then with the moon glow part of lab 1, we're giving you practice with doing CN and distinguishing between ints and strings. So I know that most of you have not looked at Moonglow yet, so I'm not going to cover Moonglow today, but I will go over Moonglow on Tuesday. So please look at the Moonglow description sometime over the weekend so we can talk about it on Tuesday. Whereas hopefully you've gotten started with lab 0.5 and with the checkerboard. We'll talk a little bit about that. Well, certainly with lab 0.5. And then we get into arrays and vectors and have some exercises planned with that. Plan to emphasize one or two things from Dr. Planck's notes that I think are particularly noteworthy. And hopefully most of this is reviewed to you, but again, it's been a while probably since you dealt with arrays and vectors. Also, you didn't spend a lot of time with them in CS102, so good to have some experience with them. And you won't deal with them in lab 1, but in lab 2 you'll deal with arrays and vectors. Okay, so you may have gone over some of the stuff I'm going to go over with characters yesterday in lab, but I don't think it hurts to hear it a second time. One of my favorite educational mantras was from a professor I knew when I first got here, a Dr. Case, who has a personal business now in Knoxville. But he used to say that the key to learning is repetition. And why is that? Because the key to learning is repetition. So with lab 0.5, where you have gold and you're kind of counting up the size of your nuggets, you may remember from yesterday that you're given a map and that some of these are the three types of characters. You can have a dot, which is dirt, you can have a dash, which is stone, and you can have a letter, which is a nugget of gold. And the bigger the letter, like D is bigger than A, the better the gold. And A represents 1 ounce of gold, B represents 2 ounces, up to Z, which represents 26 ounces. And the lab says that you need to count the number of ounces of gold in the map. So first of all, this is an exercise in reading characters because you need to read a character at a time. So you need to have a single character variable declared, which is going to hold your next piece of data that you read, which is going to be a char. So we always want you to choose something meaningful. So might call the next character land. Because supposedly you're mining land. And you don't have to worry about reading a line at a time. Some of you may have tried to read an entire line using getLine, but that's not necessary for this lab. Okay? So for this lab, you can just write something that looks like this, and it will automatically read each character. Now the question is, why don't you have to worry about end-of-line characters? Can someone tell me why this loop would work and it wouldn't, why it will read past the end of the first line and start on the second line, and why it won't unnecessarily read, say, an end-of-line character? Yes?
Yeah, polling operation in terms of Boolean value.
Pardon?
Reading it Boolean value.
You're right. So it returns a Boolean value.
Which tells you whether or not it's successful.
Okay.
If
But
it's unsuccessful, it stops.
right, but okay, so let's say it gets to the end of the line here, which is, well, you can't see it, there's kind of a \n sitting there. And I guess what I'm saying is that somehow magically, once it reaches this B, it's going to naturally pick up with the first character in the second line. Yes?
If the C is a string and it will ignore space, add and underline.
Very good. So CN ignores white space. And white space includes not just blank spaces, but tab characters and new line characters. So when the CN statement reaches this new line character, which is invisible to you, that new line character is automatically inserted into a file when you hit the return button on your keyboard. So it's an invisible character that's actually present in the file. And when the CN operator or stream sees that new line character, it ignores it because it's white space, so it moves on to the C. The other important thing to remember about streams is that while as humans we see the input formatted on a line basis, so we see lines, that's not the way it's seen by CN. CN sees this right here as dot dash dot A dash dot B backslash N C dot, say, D E new line. So it sees it as one long line of input that has some new line characters in it. So the computer doesn't view the input stream the way we do. For us, an editor like VI produces a nice formatting of the input. But to the input stream operator, it's just one long line. And it has some backslash N characters embedded in it, which it ignores because they're white space. So that's why this loop right here works just fine. Now, the second thing, hopefully, might have mentioned yesterday in lab, and if not, I'm mentioning it, is that it's not necessary to write 26 if statements that say, if land equals A, then add 1 to gold nuggets, else if it's equal B, add 2 to gold nuggets, else blah, blah, blah. You get the point. Another way you could presumably do it is using a switch statement. Okay, so you could switch on land and say case A, add 1, case B, add 2, case C, add 3. But that's also tedious. So there's something you can take advantage of with characters that allows you to do this more easily. Can someone tell me what that thing is? Yes?
Characters can be read as their Ascii values.
You can read a character using something called their Ascii value, or you can treat a character as an integer. And if you don't remember from either 102 or 130, characters are represented using an integer value internally, what we call an Ascii code, because it was invented at Bell Labs and it stands for American Character Standard blah, blah, blah. I forget what it all is. But at any rate, they assigned values from 0 to 127 to the different characters. Now, obviously, A through B, capital A through capital Z only takes up 52 of these 127 characters, and 0 through 9 takes up another 10. But there's a whole bunch of other characters. \n, which is the new line character, is given a character code. Period is given a character code. Question mark is given a character code. They're all given character codes. So if you go and actually Google for Ascii character code, you should get a whole bunch of tables that will show you what each character maps to. So you can see, for example, that 0, make it a little bigger, 0 is represented by the Ascii character, the integer 48, 9 by the Ascii character 57. You can see that the character, the uppercase A, is represented by the Ascii character 65. And an important characteristic of the Ascii character set is that contiguous characters have contiguous integer codes. So capital A is followed by capital B, which is followed by capital C. What that means for our purposes is that, as the person noted, we can treat characters as integers for certain purposes. One of those purposes is subtraction. We can subtract one character from another character. So for example, let's say that land has the character D in it. What I can do is I can subtract the character capital A from land, and that will perform integer division. In this case, it subtracts the Ascii value of A, which, if you look back here, is 65, from the Ascii character value for D, which is 68. So we get a value of 3, which in fact is the distance between A and D in the alphabet. Okay? If you remember, that's not quite the value for D. Okay? D should translate to 4 ounces of gold, not 3. So what do you think we have to do? You have to add 1. Okay, now I'm not writing out the complete code here. You have to finish it, but that little equation will convert any character between capital A and capital Z into the appropriate number of ounces of gold. Okay, and I see some puzzled looks. Anyone care to share the puzzledness with me? This is clear? If you're puzzled, please don't be shy. That's what I'm here for. We're good? Okay. Yes?
If you've already turned in the lab doing it the more tedious, longer way, that's fine too, right?
Yeah, I'd kind of rather you go back and do it the right way, just so you learn the right way to do it. Because it takes a moment. You can code this. Once you know how to do it, this program can be written in under 5 minutes. Okay? It just knows. So it's not going to be a big, especially in your case, I know you know how to do it. You can do it real quickly. Please don't. It's going to take, it's once you really understand it and you see the final program, you think, if I knew how to do it, I could have done it in 5 minutes. It takes you longer to do it than that. So that's the basic thing here. And then obviously you have to exclude anything that's not capital A and through capital Z. Yes.
What if instead of subtracting the character, we actually went and subtracted the integer value from that? Would that be okay?
That works too, because the compiler is smart about anytime you have an arithmetic equation involving a character and an int, it will do the conversion. Now, just in general, as a style issue, it'd be better to subtract off A, because for someone reading your program in the future, it's going to be a little, not everyone knows what the ASCII character code for A is, but everyone understands what the capital letter A is. So just for readability, it's probably better to write it as. But you don't need to go back and change it. I'm not the TA. Okay, and the TAs actually have 20 points where they do style, and I bet one of the TAs may get a little snit on that one. So, okay. So this is a trick that you'll use periodically throughout this semester. This isn't the only lab in which you will take advantage of the fact that characters are contiguous. In another lab later, you'll take advantage of the fact that the integer values 0 through 9 are also contiguous in the ASCII character codes. Okay, yes?
Can you assign a char by integer like a
Yes. The question is, could you assign, if I have char land and I have an int x, am I allowed to say x equals land? And the answer is yes. Okay, and it will assign the value, in this case 68, if land is D, it will assign the value 68 to x. So it will make that conversion for you.
Can we do the opposite? Can we say land equals
Yes. So you could say this as well, although this might get you a warning message from the compiler, because the x could have a value that's not between 0 and 127. In general, when this is called safe. This is a safe assignment. This is an unsafe assignment. Okay, because when you go from land, that's a char, so it's going to be restricted to the values 0 to 127. Okay, so an integer can be anything from effectively minus infinity to plus infinity. Obviously, there's caps on either side because of the inability to represent infinite numbers. But still, x can accommodate any number that land will hold. But the second assignment, that's not true. X could have a bigger or smaller number than land can hold. So that should generate a compiler warning message at the very least. Okay, but so it's just, you might see the same thing if instead of land being an int, if it were a float, you'd get the same warning messages, because one assignment is safe and one is unsafe. Okay, other questions? Okay, so in Lab 1 in Checkerboard, you also will be dealing with characters. And there, it's not as intense on the character thing, but in Checkerboard, let's just have a look at the Checkerboard lab. I understand you may not have read it thoroughly, so I'm not going to go into a lot of details, but basically the idea is you have these cyclic patterns like A, B, C, D. And the idea is that you have a starting character. It doesn't have to be A. Let's say you start at F and the cycle is 3, then the cycle would be F, G, H. Okay? And the thing you have to test for here is that sometimes he doesn't want you wrapping around. That is, if you get to a certain point, actually, I'm forgetting now, it may be trying to, let me check something real quick. I'm going to look at my answer. Actually, I have to do something here. So one of the tests you'll find that Dr. Planck has in his labs is that he doesn't want the start character, which I'll represent as start char, plus the cycle size, which in this case was 3. He doesn't want it to exceed the last character in the ASCII character set. So you'll find that that is one thing that he kind of wants you to test for in his in that lab. So that's where again you'll end up treating the ASCII characters as integers. In fact, cycle size is an integer, but start char will be the starting character, and you'll have to add the two together. Now, I will warn you in advance, Dr. Planck doesn't, in his lab, tell you where the errors are. And students get frustrated with that, but that's what the grade scripts are for. And you say, well, what good is it if you don't tell me what errors I have to check for? Well, in this class, we want you to start thinking about errors that you should be checking for. In the real world, your boss isn't going to say, oh, there's this error, and this error, make sure you check for them all. In the real world, you have to figure out where the possible errors are. So, Dr. Planck doesn't tell you always what the errors are, but forces you to come up with them. Now, because this grade script is picky, you do have to figure out from his grade scripts what the error message is. So, you can certainly do that by concocting bad data and seeing what his answer produces, because he always gives you a correct program. So you can always give it input, see what output it produces, and make sure that your program mimics his output. Okay, but that's the reason he doesn't just sit there and give you a whole set of error messages. He wants you to figure out what types of errors you want to check for, and then he gives you the tools to figure out what the error message should be, and you can put those error messages into your program. Okay, so that's the advantage of having the grading scripts, and that's the advantage of having him provide you with an executable that always gives you an answer to any set of inputs. So you can see what you can experiment. That's a big thing with computers. Experimentation. You have to be able to tinker. Okay? So questions about any of this? Okay. So as I said, Tuesday we'll go over Moonglow. So please look at Moonglow over the weekend so that you come to class prepared on Tuesday to have a chat about that. And we will turn our attention now to vectors and arrays. So both vectors and arrays, just quickly because I'm not going to spend a lot of time, you should have looked at it, basically are a way of storing some homogeneous data in a vector of some size. I'll give it a specific size here. So this is a vector or array of size 10. They look the same if I draw them, and you can access them both the same. So if this is A, both of them can access their elements using this square bracket notation. Remember that your indices start at 0 and therefore go up to 1 less than the size of the array or vector. So in this case, the size of this array is 10. So the indices go up through 9. Now, there is a slight difference between vectors and arrays. Can someone tell me what is the fundamental difference between a vector and array? I'll take you. Of a what?
Array.
Correct. So you cannot change the size of an array, but you can change dynamically the size of a vector. So an array is fixed size, and a vector can be dynamically resized. So a vector has the operation pushback that dynamically adds a new element to the vector. An array has no such thing. So a vector has pushback. Whoops. Uh-oh. Looks like, see if it's going to keep doing this. So it adds a new element to the vector. Okay. I'm going to have to go and use the whiteboard for this because unfortunately the smartboard is messing up royally right now. Okay, so pushback X, it adds a new element to, well, let's say increases the size of the vector by 1. And stores X in that new element. And then it has also a resize command that will set the vector to this new size. If for some reason the new size is less than the current size, it eliminates any elements in the old one. So for example, if my old vector had 5 elements, and I did a dot resize 2, then the new vector would look like that. Whereas more likely, I'm resizing it so it's bigger. I forget what I just had in here, so whatever it was, it adds 3 new elements, 5 new elements. Usually it will put some default value in here. For integers, that most likely is going to be 0, but you can't be guaranteed that. Okay? So normally in this course you will use vectors, but you should be aware of, because vectors seem so much nicer, right? They dynamically resize, you don't have to worry about them. They also have bounds checking. The book is very big on this. With the book, not only can you access an element using this notation, but you can also do it using this notation. Can someone tell me what is the difference between this type of access and this type of access? Yes.
This is just a guess, but I think the latter will.
This one.
Yes, that one will flag it if it's an invalid index.
Very good. So this one will flag it if it's an out of bounds access. So if index out of bounds, an error message is printed and the program is terminated. Okay, whereas here, you don't know what happens. The behavior is arbitrary. And with an array, what happens in this case is you get garbage if the index is out of bounds. Like if the index is negative, or if it's bigger than the size of the array, you get garbage. So a vector seems to have a lot of advantages over an array. Okay, not only does it can be dynamically changed in size, but you can use this access operator to ensure that if you ever accidentally access an element that's out of bounds, then that access will be flagged with an error message and your program will terminate. So does anyone know why, given all of these advantages for a vector, why you would ever use an array? Okay, you have to import something, but that's, I'll let this gentleman. Very good. Because arrays are more efficient. Okay? Think of a vector as a big, bulky luxury car. Okay? All those extra features weighs it down and it's not as fast. Whereas a race car is very devoid of features, but it's very fast. Okay? So an array is much faster than a vector, and we care about speed when we write our programs. So if we know in advance the size of our data, or sometimes if in advance we can bound the size of our data, we may choose to use an array rather than a vector because the array is faster. Now, as I said in this course, we will predominantly use vectors, but you should know, just for general thing, arrays are faster, i.e. more efficient, than vectors. So if you know in advance the size of your data, the array is a better choice. Okay. So, having done that, what I would like you to do, if you brought your laptops, there is a exercise. Whoops, that's not it though. There we, no, that's still not it. Darn it. Okay, here it is. So I want you to go to section 5.4 in the Zianti book, and there's a challenge activity called 5.4.4. There's also a participation activity called 5.4.4. So I don't want you doing the participation activity. I want you doing the challenge activity. And what you're doing, let me switch over to presentation mode. Oops. Oh man, don't wipe it out. Okay, so what you're doing is you're being asked to sum a set of variables. So what I want you to do is, actually it's asking for the number of people. No, actually, I'll let you read it and do it. So I'm going to also try to center this so that if you don't have your computer here, you're still able to do it. So it says down on line 16, your solution goes here. Actually, I can make this bigger. There we go. So it says your solution goes here. Okay. Can I make this just a little bit bigger? There we go. that pretty much gets it. So even if you don't have the laptop here, you should be able to do this with paper and pencil. So I'm going to give you about 5 minutes to try to work through this example. Then we'll go over it. Make sure you read it too, because you may have some issues. By the way, it's fine to work with your neighbor on this. This isn't one of those things that we're grading, so it's fine to talk to your neighbor about this. And I'm going to give you about a minute, and then we're going to go over the solution. Okay, so let's go over the solution. So we're being asked to find the total amount of extra credit that was earned by the students on this exam. So anything over 100 is considered extra credit. Now I'm going to start by doing some things either that wouldn't be optimal or that is wrong, and we'll correct them. So I'm just going to start with the for loop. Okay, so it starts at 0. Remember, zero-based indexing. Don't jump all over me. This isn't the best way to do it, but I know that there's 4 elements in that vector. Okay, so ask for each one of them. The name of the vector is test grades. So I'm going to ask, is test grades greater than 100? And if it is, then I'm going to assign to sum extra the difference between test grades and 100. Okay, and at first glance, this probably should get the job done. So I'm iterating from 0. I have I less than 4 because there's 4 elements in the vector. Therefore, the last of the indices will stop at 3, so I don't want to get all the way to 4. Then I test to see if the value in that position is greater than 100. And if it is, then I know there's extra credit. So I calculate the amount of extra credit and add it to sum extra. Okay, and I run it, and it's not going to work. So expected value 8, year value minus 9,991. So what did I forget to do? Initialize sum extra. So up here it told me at line 9, said set sum extra to be 0 before your for loop. So let's go ahead and do that. And I'll run it again. Now this time it says, whoops, testing for course grades, and it went wrong. So the first one worked, but the second one, expected value 0, your value 7. So what went wrong on that second test? Excellent. I hard-coded the 4 into my code. And it wouldn't have done me any good to say numvals either, because that still would have been hard coding the 4. Okay, so in the second test, they didn't fill up the vector. They only provided 2 elements. So how can I test for the size of a vector? Yes?
.at function?
Okay, that won't test for the size. That will, at is an accessor. That-
It just has the, I got it.
Size.
Do you want to create stuff size?
Dot size. So what I need to say here is if it's less than test grades dot size. And that way it will stop when it reaches the end of the current size. So what was happening here is in some sense they were setting up for the capacity of the vector. It's like a car. A car might be able to accommodate 6 people. But just because it can accommodate 6 people doesn't mean that it is actually carrying 6 people. So we make a distinction between the capacity and the size. The capacity is the number of elements an array or vector could possibly hold. The size is the number of elements it actually holds. So in this case, the capacity is 4, but the size varies. Okay, so if I run it again, everything should work out just fine, and it did. Okay, so questions about that code. Now, okay, 2 questions. Actually, let me say one other thing before it. I could have made this safer by putting an at here. Okay? I don't care which way you do it in the labs. In class, just because I'm old school, you're going to see me do it this way, which is more dangerous because it won't catch it if something goes wrong. Let me actually put at I here and put the 4 here again and see if it would have caught the problem on the second test. So we'll run it. Okay, and runtime error. So see, by using at, I got a more informative error message. Runtime error, common due to an invalid array or vector access, test aborted. So the at gave me a little more information, although unfortunately it didn't give me a line number, which is what I really would have liked. But the at is a little more informative when things go south than this is. So this is faster, but this is safer and more informative. Which you use is up to you, although when you're debugging, I would probably use the at because it's more likely to give you an informative error message. Okay? Now I'll take the questions, yes.
If you use numvals, it works.
Oh, that's bad. Okay. Well, I think what they're doing is probably changing the value of numvals. So that's fine, but don't do that. Basically, when you're using a vector, it allows you to query the size of the vector, and I always do want you to use dot size, okay? So numvals is better than hard coding it, but best is to use size. Other questions? I seem to have answered the gentleman over here.
That's all.
Okay. Yep. So in general, with vectors, we don't actually hard code the capacity because, in fact, we can dynamically increase the capacity using pushback. Okay. In the examples in the book, they often hard code the data just because in the book it's really hard for them to set it up so that you can input data dynamically. Obviously, in a program, this would probably be more like a for loop. In lines 11 through 14, it'd be more like while seeing into something, do a pushback and add to it. So in a real program, it would be more likely that you would see something like as your way of initializing the loop. okay, or the vector. So that would read a score, and then it would push it into the vector, dynamically increasing the size of the vector by 1. So that would be the more common way you would see it in a real program. Okay, so questions? Yes?
Once you've built your vector, can you then have it be an array?
Once I have it as a vector, can I change it to an array?
Yeah. So
Ye-
once you've got the size, can you then say, well, no, I'm just going to
Well, the problem is if this data set would always be reused, the answer would be yeah. Okay. Is your question, can you dynamically do it in the program, change it from a vector to an array? Or is it, can you do it? There's two. One is no, if it's in the program itself, you can't at runtime change it from a vector to an array. You're stuck. But if after running it, you kind of, a number of times, you feel like you know the upper bound on the size of your data set, you could go back into your program, change it from a vector to an array, recompile it, and do it. But that only works if you're absolutely positive you now know the upper bound.
Right, so you can't just go, I've got a bunch of data, shove it all in the vector, and then change it to one.
No, you can't. Nope. So once it's kind of like that, once you run the program, that boat has sailed. Okay, you're stuck with the boat you bought. Okay, other questions? Yes, no, nope. Others? Okay. So I'm going to wrap it up here on, we're going to do a couple more things on Tuesday with vectors. We're going to specifically, I'll tell you what we're going to go over with Dr. Planck's notes on Tuesday. So I expect you to read through Dr. Planck's notes quickly. I know I didn't go through string basics. Those are pretty easy, but make sure you do it. I will touch on getLine on Tuesday because that's important. Also on Tuesday, I plan to go through the bug at the back end of his code, and I also plan to go through his example with reverse and tail. Actually, I plan to go through his example with tail. So getLine, tail, and the bug are 3 things I'll go over on Tuesday. Come up here.